Now, without further ado, it is my pleasure to introduce our first speaker today, Dr. Fran Wilkinson. I've known Fran for a long time. Fran is an Emeritus Professor in the Psychology Department at York University and an active member of YU Care, which is our Aging Research Institute, the York Center for Vision Research, and VISTA, which is Vision Science to Applications at York. Over the course of her career, she has conducted research on many questions about vision and the brain across the entire human lifespan, from early development to aging. And she's also well known for her work on vision and migraine headache. More recently, her focus has turned to the interface between vision and lighting. And she's particularly interested in how recent advances in lighting technology like the LED revolution could make the built environment more user-friendly for us as we age. Among her post-retirement activities, she has given a course on light and the older eye, steps to healthy visual aging through Ryerson's Life Institute. Take it away, Fran.
Thank you, Suzanne. So I'll put my slides up. I hope everyone can see them. Yes, well, thank you everybody for coming. So I want to talk about light and older eyes. These are not normal times we're living in. Everybody's lives at the moment are a series of risk assessments. We make decisions, including whether to seek eye care, based on our own vulnerability to COVID-19 and the vulnerability of those in our living bubbles. So with this in mind, my goal in this talk is to explain some of the changes that occur to our vision or to our eyes during normal aging, what consequences there are both for our vision and for our health in general, and what we can do to compensate for these changes under our current very restricted living conditions. So overall, my takeaway message from this talk is very simple. Our goal should be to make vision as effortless as possible for our older eyes. I'm going to leave discussion of cognition to my colleague Dale, but to suffice to say that badly degraded input can't help but pose an added challenge for our cognitive processes. My second message is that light is our best friend in achieving both the goal of effortless vision and better health in general. I'm going to limit my discussion today to normal aging, but of course there are eye conditions that are not normal, and I can try to address questions about some of those in the question period if there's time. So to talk about light in the eye, there's two properties of light that we have to understand. The first is wavelength. So here is the visible range of light going from 400 nanometers to about 700, and the perceptual correlation with wavelength is color. The second property of light that's important is its intensity, and the correlated percept there is brightness, and the human visual system has an incredible range of intensities that it can respond to. In fact, a factor of log unit 10 to the 13 range, which is enormous, although we don't do this all at one time. So our visual system adjusts to ambient light levels, so we're not normally aware of how huge these differences are. But as you can see in these pictures and the measurements I made when I took them, the amount of light available at our eye and outside in a daylight situation could be as much as 10,000 times more intense than what we see, for example, in the office that I'm giving you this talk from. So the human eye uses light for two different sorts of things, and I'm going to try to address both of them today. The first is for vision, obviously, and the second is to synchronize our circadian or 24-hour rhythms. So let's start with vision. For vision, our eye acts somewhat like a camera, producing a focused image here at the back of the eye on the retina. This is a blow up of a little piece of the retina. And the retina is like the digital sensor in a modern camera. Our photoreceptors here capture the light, turning it into nerve signals from several million individual receptors or points on the retina. So like our camera, we have megapixel vision. These signals are sent from the eye through the optic nerve to the brain. And this process seems very effortless, at least for younger eyes. The effort comes in at the higher levels of cognitive processing where we have to decide whether we actually recognize the face we're looking at or what that movement was in the bushes. We have another group of photoreceptors, and these send signals measuring light on the retina to a tiny part of our brain on the underside of our brain called the suprachiasmatic nucleus. And this information is used to synchronize a whole range of our body functions that have approximately 24-hour rhythms. The most obvious of these is our sleep-wake cycle, which is determined in part by fluctuations in a hormone called melatonin, which you can see here. It reaches its peak in the middle of the night and is at its lowest during the daytime. And if we get too much light of the wrong wavelengths, especially short wavelengths in the middle of the night, we'll have trouble sleeping. And if we get too little during the daytime, we may be very drowsy. So melatonin and several other hormones, along with body temperature, blood pressure, and various other functions, all work on a 24-hour cycle. But without the synchronizing effects of light, they can fall out of synchrony, causing a wide range of problems. And here I've listed some of the problems that people have been studying in recent years that are linked to poor circadian entrainment. And I just want to emphasize the first two because we've been hearing a lot lately about how people are suffering from both sleep disturbances and depression during this COVID lockdown that we're all going through. Now, I want to just show you very quickly the photoreceptors, and particularly to talk about the cones. The rods, these skinny ones, operate under low levels of illumination at night. The cones, of which there are 3 different sorts, operate under higher illumination, and they provide the basis for color vision. If you look over here on the right, you'll see that each of those cone types has a different range of wavelengths that it's sensitive to. And each of them has a peak sensitivity at a particular point on the spectrum. So one peaks in the blues, one in the greens, and one over in the yellows towards red. And I also want you to notice that the blue sensitive cone is much less sensitive overall. It absorbs a much smaller fraction of light than the other 2. Now here we have the photoreceptors that I'll call the melanopsin cells. Their official name is intrinsically photosensitive retinal ganglion cells. And I had to draw them into this diagram because they were actually only discovered in 2002, whereas the others we knew about a century ago. So these are the cells that register overall light level. So having said all of that, one more thing about those. I just want to point out that their peak sensitivity is also in the short wavelength end of the spectrum, down near the blues. And that will be important in a few minutes. So now turning to aging, I want to just mention some of the major changes associated with aging in our eyes. The first one, I'm sure we're all familiar with, anyone over 45 is, this is presbyopia, the fact that it becomes more and more difficult to focus on close objects. And that's because the lens in our eye gets more and more stiff and we can't change its focus. The ones I want to focus on today, though, are these 2 points, that the eye gets increasingly little light coming into it as our eyes get older, and the neural processing slows down somewhat so that we are slower at adapting to changes in lighting. So if we go from light to dark or from dark out into bright sunlight, that takes longer to adjust. And I want to focus on those 2 things right now. So why is there less light getting into our eye? Well, there's several reasons for that, but I'm going to focus on 2 of them. The first one is changes to our lens. Not only does the lens of the eye get less flexible as we age, but it also starts to yellow and it becomes more dense. So less light goes through it, and that light that does come through is from the longer wavelengths, more in the yellow range of light. In extreme cases, we may develop a cataract, and that will cut down the light even further and will also scatter the light, so it will become very difficult to form a sharp image on the retina. The other thing that happens is our pupil size changes, and this is quite a big effect. So this graph shows you changes in pupil diameter with age from 20 to 90 years. And you can see that those changes are particularly big for dim light. And I show that down here in terms of the area of the pupil. So while the differences aren't too big under bright light, where we want to have small pupils, under dim light, where we're trying to get a lot of light in, the younger eye is getting a lot more light than the older eye. And in fact, the light levels in an older eye may end up being as little as a quarter of the amount of light we're getting in a younger eye. So that's a big change. And many older people are aware of this, although they may not know why. So they'll tell you, my house seems very dark these days, or why is this restaurant so dark? So because the lens yellows, that also has an effect on our color vision, as you can see here. So while these colors are just a little less intense, down in the blue range, it's actually hard to see color at all because yellow filters are filtering out the short wavelength light, which we're not very sensitive to in the first place. So you can see here that colors are less intense, and we see purples and say the blue in my sofa as blacks, and it's hard to distinguish our black clothes from our blue clothes, and many older people will experience this. It's important, though, to notice that those melanopsin receptors are also down in that range, so they too are going to be selectively deprived of light by this yellowing of a lens. Secondly, because the overall light level is reduced, this is going to affect vision in some other ways. So in this figure, if you move from the top to the bottom of the figure, you have increasing contrast. That contrast is the difference between the lightest and the darkest point in the image. And as we move across the image this way, we have finer and finer detail. So in normal vision, you can see that there's an area that we can see, which is best in the middle range. And then as details get finer, we need more and more contrast to perceive them. What happens when we reduce the light? Well, this simulates that effect. And now you can see that we lose the fine details completely, and we need higher contrast. We need to be down at this part of the image in order to see differences at all. So this is sort of a simulation of what might happen with an older eye under normal lighting, or a young eye if you were to test them under very low levels of illumination. So I want to spend the rest of the time giving you a little toolkit for how to deal with these changes to our eyes. First of all, it is really important to try to get a daily dose of daylight outdoors if at all possible, because as you saw at the beginning, the intensity of light is much higher out there, and your circadian system really needs that light. So even if it's only for a few minutes, try to get it in the morning. That's when it's most important. Try to get some real daylight. And if you can't get outside, then be very close to windows, because you don't have to go far into a room for that illumination to fall down to very low levels. The second thing I'd say is try to improve your task light. This light provides general illumination, but you can't tell at all what's down here underneath it. In fact, with a nice task light like this little one that I got from IKEA for 10 bucks, you can actually see my CD collection and read the titles. Another useful thing to do, even though we are attached to our newspapers and books, is to consider switching to a self-illuminated, take that off for the moment, tablet, because with a tablet we can scale the size of the fonts and we can change the brightness, and so we can get a much higher contrast image. And here's a case that I think is really important. Drug companies seem to put all the critical information into minuscule type on their pill bottles. But you can use either a magnifier with a light, which I'm sure you can buy on Amazon or from the CNIB, or you can use your cell phone to take a zoomed in picture and then zoom that in even more so that you can actually read these critical instructions about what these drugs might do to us. Turning to the slower adaptation I mentioned to changing light levels, one thing I suggest is transition lighting, So if you're going to be outdoors in bright daylight, it's a good idea to leave the hall light on so that when you come inside into your dark house, you have a period of transitioning into lower light levels before you're in really dark conditions. Secondly, strongly recommend that you go around your house and eliminate obstacles, especially on what I'll call the bedroom to bathroom route, which all older people will understand. So it is not wise for me to leave my cell phone charger on my carpet, and similarly any other difficult to see objects. It would be a good idea to keep them removed. Finally, I can't emphasize enough how important I think it is to use night lights, because during the night we don't want to light adapt our eyes. We don't want to go into a different room, turn on a bright light, and then come back into a dark bedroom where we really won't be able to see anything. If we can keep an overall low level of illumination along any path we're likely to take, that is going to significantly reduce our risk of a fall. And in these pandemic times, the last thing we want to do is fall. So now turning finally to presbyopia, the only thing I want to say here, we know that glasses, reading glasses, progressives are the thing that will help us. I just want to emphasize that your prescription belongs to you. So if you need new glasses, you're perfectly in your rights to call up your optometrist and ask for your prescription. If they can't provide new glasses and you have to buy them online, that is better than nothing. And I suggest you use either light dark contrast or else bright colors to help you find things easily when you in situations where you might not have your reading glasses. So here's a drawer from my own kitchen, and you can see that my favorite cooking tools I can easily pick out because each one is a different color. My spatulas, my scissors, my measuring spoons. And sometimes we can't use our glasses at all, like in the shower, for example. I'm sure you've all had this experience, either at home or in hotels. You take off your glasses and you have no idea which of these bottles is which. So sometimes we have to give up our brand preference in order to be able to use color to see things easily and to make our vision a little more effortless. So having said all that, my final messages are these. First of all, if you already suffer from an eye disease, it is really important to continue your treatments or medications during this pandemic. So if you have glaucoma or diabetic retinopathy, for example, be sure to stick to your treatments. Sudden big changes in vision are not normal. So if you suddenly lose vision in part or all of your visual field, if you suddenly experience extreme blurring, if you suddenly have the onset of flashing lights and they don't go away, or if you suddenly have very intense eye pain, especially if it's accompanied by nausea, these are all signs of serious medical problems, so you will want to seek medical attention. Also, remember that every pair of eyes is different. We age at different rates, and the changes I've talked about happen at different rates in different people. So you need to be your own vision scientist and try out lights and try out changes to your environment that will help you see better. And finally, never say it's just part of aging. There's nothing I can do about it, because actually, usually there is something you can do about it, and I encourage you to try. So saying all that, I just want to show you a few websites which you'll be able to access later that provide a lot of information about the eye and aging that could be quite helpful, and say thank you for listening.